section 1.6, using units and solving problems. So in this course, we will do lots of problems, lots of calculations, lots of problem solving. So having a method for solving problems can be very helpful. So we're going to talk about a tool here which is referred to often as what's called dimensional analysis. Dimensional analysis is a sort of bookkeeping. What you're doing is you're keeping track of units. So for example, suppose I had some kind of problem, and the problem said find the length. And so I'm going through the problem, and I find that the calculation involves units of meters squared divided by meters. And I would note, hey, meters are in the numerator and the denominator. So I can cancel the meter in the denominator with one of the meters in the numerator and then get the units of meters out, right? And then you can ask yourself, if I'm trying to find the length of something, are these units consistent with length? And based on our discussion in earlier sections, the answer is yes. Length is often measured in the units of meters. So that tells me that there's a possibility that this is going the right way, that we did the calculation correct. It's not proof of it, but it's at least some evidence. So the way we begin with this is by talking about what are called conversion factors. And you'll see all sorts of conversion factors in this course. Here's a common conversion factor. 1 inch is equal, by definition, to 2.54 centimeters. So that's a relationship between centimeters and inches. But we can write this as a conversion factor in the form of a ratio. If we divide both sides of the equation by 2.54 centimeters, on the left side we would have 1 inch over 2.54 centimeters. And on the right side we would have 2.54 centimeters divided by 2.54 centimeters, which is just 1. So what that tells us is that inches divided by centimeters, 1 inch divided by 2.54 centimeters, is 1. Likewise, we could have divided both sides by inches. Had we decided to do that, we would have 1 equals 2.54 centimeters divided by an inch, right? Now 1 is on the left side because 1 inch divided by 1 inch is 1. And then we can use these conversion factors in order to do calculations. So for example, suppose we said there's a measurement. Someone makes a measurement, and the measurement is length, 12 inches. And we want to convert that to centimeters. What we would do is we would pick one of these two conversion factors. Only one of them is the correct one. Which one do you think it is? It's the second one. It's the one on the right. And here's why. Here's a way to tell in any case. If you take the measurement 12 inches, 12.00 inches, and you multiply that by 2.54 centimeters per 1 inch, the inches divided by inches is 1, and our answer will be in centimeters. Now let's apply the rules of significant figures to that calculation. 12.00 inches is the measurement. How many significant figures does 12.00 have? You have 1, that's significant. 2 is significant. There's a decimal, and then you have trailing zeros. So that means the zeros are also significant. So all 4 are significant. There's 4 sig figs. This is a definition. So it's an exact number. So when you have a calculation that involves an exact number and an inexact number, the answer, the number of sig figs in the answer is going to be determined by the inexact number, the inexact value. So this one has 4, so this one also has 4. Okay? Let's take another one. A meter is the same as 100 centimeters. So we could write this as 2 conversion factors. We could divide both sides by a meter, and we would have 100 centimeters per meter equals 1. Notice that I divided both sides by meter. 1 meter divided by 1 meter is 1. 100 centimeters divided by 1 meter is 100 centimeters per meter. Or we could have divided both sides by 100 centimeters. So we could also have 1 meter over 100 centimeters equals 1. So you can get generally you get 2 conversion factors for each identity. This would be called an identity. Something equals something else. They're identical, even though they look different. And so that allows you to get 2 ratios. So suppose we wanted to do a conversion into meters. We could take our 12 inches. So we're going to go back to the original measurement. 12 inches, that's our original measurement. And then we said, hey, it's 2.54 centimeters per inch. And suppose we want to convert it to meters. 1 meter is 100 centimeters. This is often referred to as a chain, where you're calculating more than one calculation in the same chain of numbers. So the original calculation we did was we got rid of inches to get centimeters, but now centimeters divided by centimeters is 1, and our result is going to be in meters. And you get 0.3048 meters. So when we do problems, we want to have the conversion factor, but remember each conversion factor is really 2 conversion factors. So right? So you have the meter over centimeters is the one we picked there. And centimeters over inches is the one we picked for the other one. Okay? So we could do 2, 3, or even 4 steps, all in one chain of calculations. Okay? Now sometimes, some of these can be a little bit tricky. So for example, if we're dealing with areas or volumes, area is generally length squared, and volume is length cubed. At least they're proportional to them, right? So when we square or cube measurements, we also have to square or cube the units. Okay? So let's say, for example, we have a measurement of 1 meter cubed. Now, even though we write it that way, really what we mean is 1 meter cubed. Everything's cubed. The 1 and the meter is cubed. Okay? But it's generally written this way, so we'll stay consistent with that. Suppose we want to convert that into centimeters. We have our conversion here. It's 100 centimeters per meter. So what I'm going to do is I'm going to multiply this by 100 centimeters per meter, but it's cubed. So I'm going to have to multiply this by, let me put x's for multiply by, 100 centimeters per meter 3 times. If we were doing area, it would just be 2 times. See what I mean? If you're cubing meters, you got to cube the conversion factor as well. So if you do this, a meter times a meter times a meter is a meter cubed. So a meter times a meter times a meter is meter cubed. So that means that 1 meter cubed is 100 times 100 times 100 centimeter times a centimeter times a centimeter, 100 cubed centimeter cubed. So this leads to quite a relationship. A meter cubed is 100 cubed is 10 to the 6th. 10 to the 6th centimeter cubed. That's quite a large relationship. And the reason for that is that if you consider a cube, I'm not going to show it exactly the scale, but I want to show you, give you an idea. Suppose we have a cube and it's a meter by a meter. Oops, sorry. Okay, let me show you the centimeter. Centimeter, so here's our length. That's 1 meter, which is 100 centimeters. So a centimeter is only that long right there. But then here a meter is 100 centimeter. So if we're going up, there's going to be 100 of these centimeters all the way up to the meter. Okay? And likewise, if we're going from here to here, a meter is 100 centimeters. So, tiny little centimeters to give you a meter. So if you ask yourself, how many of those little centimeters are there in a meter? Well, it's 100. So how many centimeters cubed are there in 100 meters cubed, or in a meter cubed? It's 100 times 100 times 100. So there's a 10 to the 6th centimeters cubed per 1 meter cubed. So it's a very large number based on the fact that we're cubing the dimensions in it and we're cubing the numbers as well.